Welcome back. We're practicing pH and pOH again. The pH of a solution is 7.5. What's its pOH? The rule for all of these is your pH and your pOH, at least at room temperature, add up to 14, which means 14 minus either p number gives you the other p number. So in this case, 14 minus our pH of 7.5 is 6.5. That's our pOH. Easy. Okay, now, not so easy. A solution is prepared by dissolving 8 grams of NaOH in 300 ml of water. What are the pH and pOH of the solution? Is it acidic or basic? Is this an acid or a base? It's going to dissolve into sodium ions, which you may or may not care about, hint, hint, and hydroxide ions. The sodium doesn't matter when you're talking about acidity or basicity, but this makes it a base. So definitely a basic solution. We expect our pH to be over 7. Now, if we want to find a pOH, because we're talking about a base, we need the OH concentration, and they didn't give us that. So the concentration is going to be number of moles divided by volume. They didn't give us the number of moles because they hate us, so number of moles equals mass divided by molar mass. This question's a whole chain of we need the OH, don't have it. We need the concentration, don't have it. We need the number of moles, don't have it. Just keep digging. If you know enough formulas, you can generally crack this stuff. Here, our mass is 8 grams of NaOH. The molar mass of NaOH is exactly 40. I know this from long practice. Check me if you're not sure. 8 divided by 40 gives 0.2 moles of NaOH. The concentration of NaOH is number of moles divided by volume, so it's 0.2 moles divided by 300 ml is 0.3 liters, gives 0.6666 and so on forever moles per liter NaOH. When NaOH dissolves, when one NaOH dissolves, you get one sodium and one hydroxide ion. So the ratio of this to hydroxide is 1 to 1. That means our hydroxide concentration is also 0. Endless string of sixes. And so our pOH, finally getting some answers, is negative log 0.66666. You probably heard me putting in too many sixes there. 0.1761 should be our pOH. And then the pH, because they wanted them both, is 14 minus this number, so 13.8239. How am I on SIGDIGs here? 3, 3, molar mass at 4, but 3 is the worst that we have, so this I should hack off at 0.176. And this, I shouldn't have that 9 on the tail end. It should be 13.824. That's better. And 494 seems to be the same idea, only with an acid this time. So we know from up here, we're thinking I can find the pH if I can do negative log H3O. But I don't have this. I could get the concentration of the acid if I did number of moles divided by volume, but I don't have the number of moles. I could get the number of moles if I do mass over molar mass. Our mass is 100 grams of nitric acid. And I feel like I should know the molar mass for this, but I don't. Hydrogen, 101. Nitrogen, 1401. 3 oxygens, 48. 6302. 100 divided by 6302. 1.5868 moles of HNO3. Concentration is the number of moles we just found, 1.5868, divided by 2 liters, gives 0.7934 moles per liter HNO3. Like before, this is 1-to-1. Every nitric acid releases 1 hydrogen, so the concentration of hydrogen and the concentration of nitric acid are the same. So our pH is going to be negative log, and the hydrogen concentration will just be this again, 0.7934. Log minus, on your calculator it might be negative and then the log key. On mine, I have to hit log and then the negative sign afterwards. And I get 0.10, we're getting 3 sig digs here, so 0.101 should be our pH. And then our pOH is 14 minus that number, which is 13.899. Sig digs are all good. The solution is acidic because this is nitric acid. And I believe that's all they wanted. Good. Fair bit of work, but manageable, I hope.